Predictive analytics is typically an incremental win journey, which is when you take a forecast, let's say to that example of a demand forecast, and I have an example where we were looking to build an unconstrained demand forecast, and the existing accuracy was in the 50s, so 55, 56%. So think about that. That's essentially saying that our human-based accuracies that we have within the current ecosystem was just about slightly better than a coin toss, if you think of it. Right. And we wanted to obviously move that to world class, to somewhere in the 90 plus, 98, 99% plus levels of accuracy. And that's something which is a journey that can happen over time. So how do we iterate and how do we build the right model so that that can consume various kinds of signals and where it can drive that incremental accuracy increase over time? And in a couple of instances, what I've had success with doing is having a model run in the background and function as a challenger to the manual process. And in many cases, it took us some weeks and months, even after the model started beating the human accuracies, for us to be able to drive that change. Because I think change management is an often overlooked point in the AI adoption journey.
Yeah.
And it's incredibly imperative for us to think through that change management journey because there are people and processes involved once the model output ends. And even with superior models that are beating human forecast, that doesn't mean that we can, just lift and shift that and change an entire process altogether. So that took us some effort to really develop. And we had some great success with proving out that over time, the model was able to perform more consistently and sustainably better than the human-based forecast. And that led to an entire transformation of a function which was tasked with building this forecast on a day-to-day basis.
Yeah, and I really liked this challenger model that you described, wherein a model effectively competes with human manual efforts. And it's like establishing a clear benchmark, because oftentimes when we're talking about AI or generative AI, we're simply talking numbers, but there's no benchmark to compare it against. And with this model that you highlighted, it's like you have a clear comparison wherein human peers achieve a certain task with a certain threshold of accuracy, and you directly have a benchmark to compare against when you deploy AI. So that's a really powerful approach that you talked about. Thank you for sharing that with us, Arun.
Yeah.
uh,
I have an interesting anecdote on that, Devang, that I think people might find helpful, which is that when we started building this, right, one of the unconstrained demand forecast, what I recognized in some of the early days through my product teams is that the statistical models and later AI-based models were great through identifying different drivers and elasticities, but they always got one thing wrong, which is the sales drive that typically happens at the end of a month, at the end of a quarter, or at the end of a year. That's a
Correct.
very behavioral based sort of an approach. So the models were not able to identify that there is a human element, which is that the sales teams typically will drive for some kind of an output towards some of these milestones, right? So they may have personal sales incentives, they may have team-based incentives that are tied into that. So whenever you had these closures or year closures, you'd have 1 month that is slightly off. And when we dug deeper into it, we recognized that there is a human behavioral element to it. It wasn't really a sort of a demand driver that was changing, but it was the fact that that's a human-based sort of a data point. So over time, the models were able to learn through that as well. That was an interesting anecdote about how data science and behavioral science actually needs to blend together to drive the best outcomes when we think about real world use cases.